In a serious collision, the car can stop in a fraction of a second, but the human body does not. It keeps moving forward, straight toward the steering wheel, dashboard, or side structure. Hidden inside the passenger vehicle safety cabin is a system with only a few milliseconds to answer 3 questions. Is this a real crash? How severe is it? And which occupant needs protection? If the system reacts to a pothole, it deploys unnecessarily. If it waits too long, the protection arrives after the impact. This is how an airbag identifies a collision, inflates in about 30 milliseconds, and begins deflating the moment it catches the occupant. During normal driving, the vehicle and everyone inside it move at the same speed. In a frontal collision, the vehicle crumple zone deforms and absorbs part of the energy, slowing the passenger compartment. But inertia keeps the crash test dummy occupant moving forward. The 3-point seatbelt with pretensioner restrains the torso and removes slack from the belt. Yet the head and chest can still travel toward the interior. The airbag creates a large cushioning surface that spreads the remaining force across a wider area. But before it can do that, the vehicle must determine whether the event is truly dangerous. The multi-axis crash sensor constantly measures acceleration along several directions. Inside it, a MEMS accelerometer detects microscopic movement of a suspended structure and converts that movement into an electrical signal. Hard braking creates one pattern. A deep pothole may produce a sharp but extremely brief spike. A serious collision creates a different combination of intensity, direction, and duration. The collision deceleration signal travels through the vehicle wiring harness toward the airbag control unit. The airbag control unit does not respond to one measurement alone. It compares signals from multiple sensors and evaluates how quickly the vehicle is losing speed. Its algorithm looks for a crash signature that matches conditions established through extensive physical testing. A strong signal that disappears too quickly may be rejected. A sustained signal that remains below the deployment threshold may also be rejected. This filtering prevents the system from confusing everyday shocks with a collision severe enough to require an airbag. Even if the main electrical supply is damaged at the instant of impact, the decision process must continue. A backup power capacitor stores enough energy to keep the airbag control unit and its firing circuits operating for the critical moments after power loss. Within only a few milliseconds, the controller decides whether deployment is necessary, but it still has another decision to make: which protection system should activate. The occupant detection system monitors the passenger seat using a pressure-sensitive mat, while the seat position sensor measures how close the seat is to the dashboard. The seat belt buckle sensor reports whether the belt is fastened, combined with the direction of impact. This information helps the controller select the appropriate response. A frontal collision may activate the dual front airbag system. A strong impact from the side may require the side torso airbag system and the curtain airbag system. Some airbags may remain inactive because deploying every module is not always the safest response. Once the airbag control unit authorizes deployment, the electrical firing circuit sends a precisely controlled current to the selected module. From this moment, the process cannot be reversed. The current reaches the pyrotechnic igniter inside the pyrotechnic gas inflator. The igniter starts a rapid, controlled reaction in the gas-generating propellant. This is not a tank slowly filling the bag with compressed air. Gas must be produced almost instantly, exactly where it is needed. The expanding gas passes through a stainless steel filter mesh. The mesh traps solid particles and absorbs part of the heat before directing the gas toward the airbag. The woven nylon airbag cushion has been folded into an extremely compact shape inside the steering wheel, dashboard, seat, or roof rail. As pressure rises, the cushion forces open the steering wheel airbag cover or dashboard airbag door along engineered seams. The opening is designed to split in a predictable direction without releasing loose fragments into the cabin. The airbag then expands toward the occupant at extremely high speed. In the dual front airbag system, the driver airbag emerges from the steering wheel while the passenger airbag unfolds from the dashboard. The side torso airbag system fills the narrow space between the occupant and the door. Above the windows, The curtain airbag system drops downward to protect the head from the side structure and broken glass. All of this can happen faster than a human blink, but the airbag must not remain rigid. As the occupant contacts it, calibrated airbag vent holes allow gas to escape. The cushion collapses progressively, converting the occupant's motion into controlled deformation instead of acting like a hard, inflated barrier. This carefully timed release is what allows the bag to absorb energy. Within a fraction of a second, it has already started to deflate. Dust or a light haze may appear in the cabin after deployment. Much of it can come from the inflator process and the coating used to help the folded cushion deploy cleanly. It does not automatically mean the vehicle is on fire. The airbag has simply completed a process designed to begin and end almost instantly. However, an airbag is not a replacement for a seatbelt. Without the 3-point seatbelt with pretensioner, the occupant may move too close to the module and meet the cushion while it is still expanding. The belt restrains the body first, controls its position, and reduces forward movement. The airbag then handles the remaining energy by cushioning the head and chest. The two systems are engineered to work together. An airbag may be used only once, but that single deployment depends on continuous sensing, backup electrical power, collision algorithms, occupant detection, controlled gas generation, precise fabric folding, and carefully sized vents. The system must distinguish a pothole from a crash, identify the direction of impact, select the correct module, inflate it, and release its pressure at exactly the right moments. It completes the entire sequence before the occupant can even understand that the collision has begun.